The great mechanist philosophers of the early modern era, am I speaking too loudly, or is that okay? Fine? Okay. Including, say, Galileo, Descartes, and Boyle, sought to portray the scholasticism they inherited from the philosophical tradition as excessively wedded to ordinary beliefs about topics like perception. Whereas the scholastics held that the blueness of my jacket is a real property of it, we are told, the modern view is that the particles of the jacket bear various properties such as size and shape and motion that lead a normal perceiver like myself to have a sensation of blue when I see my jacket. They also sought to underscore how neo-Aristotelian notions of causation were tied to outmoded philosophical preoccupations. And so, again, we are told, they rejected 3 of the 4 classical idea from Aristotle, settling just for efficient causation. They then tied these 2 strands of thought together, contending that all change within nature should be understood as involving efficient causal relations between bodies that are characterized by a short list of properties like size, shape, and motion. And for some of the mechanists, like Descartes, this conception of material bodies and their causally relevant properties enables us to conceive of material changes as being susceptible to mathematical analysis. For if we forget about the blueness of my jacket and focus on its size, shape, and motion, then we can think of it as inhabiting the world of geometry. And then the mechanist explanatory project is off and running. Okay. All very obvious and well known. Now, Newton had grown up reading the great modern philosophers like Descartes, Boyle, and Hobbes during his undergraduate years at Trinity College in the early 1660s. And Newton sought to align himself with their generally anti-scholastic, anti-Aristotelian views. He said so in the very first sentence to the first edition of Principia Mathematica, which was published in London in 1687. And that is the first thing on your handout. Let me just read this, although many people will know this very well. The first sentence of the first edition. Since the ancients, according to Pappus, considered mechanics to be of the greatest importance in the investigation of nature and science, and since the moderns, rejecting substantial forms and occult qualities, have undertaken to reduce the phenomena of nature to mathematical laws, it has seemed best in this treatise to concentrate on mathematics as it relates to natural philosophy. And as we know from much earlier scholarship in Newton, this is clearly meant in part as a dig at Descartes, who Newton thought had failed to really use the most sophisticated mathematics in his thinking about natural philosophy in Book 2 of Descartes' Principles. If we allow Newton here a rhetorical nod to ancient wisdom, considering it as a typical flourish of the late Renaissance, we find Newton aligning himself at the very opening of his text with those natural philosophers who wish to reject scholastic principles, replacing them with a mathematical treatment of natural phenomena. Hence it seemed right from the start that Principia Mathematica would be a welcome addition to the growing panoply of broadly mechanist tracts in natural philosophy near the end of the 17th century. But if a mechanist reader of the Principia were to turn the page, she would have found some confusing elements in the very next part of the text, the definitions. I give here just definition 1, thank you, definition 4, definition 5. There are 8. I don't go through all of them. But let me just talk a little bit about the definitions. The very first definition adopts Cartesian terminology. It concerns the quantitas materiae, the quantity of matter. But unlike Descartes, who thinks of this quantity as the volume of an object, Newton tells us that it should rather be considered as proportional to a body's weight. He says that he would refer to this property as the mass of an object, right there in the comment after the definition. but we do not yet know that it can also be considered as a measure of a body's resistance to acceleration. This does not sound terribly problematic from a mechanist point of view. Similarly, definition 4, which tells us that an impressed force is the action exerted on a body to change its state either of resting or of moving uniformly straight forward, is also not completely alien to the mechanists, for Descartes had spoken long ago of forces in his third law of nature, which again is in part 2 of Descartes' Principles. That was originally published in 1644 and very well known to Newton. If Newton wished to say, for instance, that when a rock strikes another rock, it impresses a force on it, so be it, as long as he sticks with efficient causation, ordinary mechanist properties like size and shape, and contact action. But Newton did not stick with contact action. As we see already with definition 5, Newton tells us that there are various kinds of impressed force, and he gives 3 examples. Is this on your handout? Yeah. Or most of it is. Here are the examples: percussion, pressure, and centripetal force. The first 2 seem innocuous enough for a mechanist. But what does Newton mean by the third? Definition 5, in turn, gives 3 examples of centripetal force: gravity, by which bodies tend toward the Earth's center; magnetism; and whatever force it is that maintains the planetary orbits. Newton's being careful here to use gravity in the more accepted notion, and he isn't yet talking about what he will call later universal gravity. Okay, this presents a problem. It's one thing to say that when 2 rocks collide, they impress forces on each other. It's quite another thing to tell us that something impresses a force on a rock as it falls to the ground, and that something impresses a force on the planets as they revolve around the sun. Are we supposed to think that something impresses a force, say, on Jupiter, which is millions of miles from the surface of the Earth? The notion of force, already in the definitions, has come untethered from its mechanist moorings. We are no longer restricting ourselves to cases that involve impacts between material bodies. We are now employing a causal notion, and remember, Newton defines impressed force as an action exerted on a body, so I take it to be a causal notion from the beginning. We're now employing a causal notion in cases that are not necessarily going to involve impacts at all. So by the end of the first few pages of the Principia, Newton's relationship with the mechanical philosophy has already become vexed, despite that first wonderful opening sentence where he seems to be aligning himself with the mechanical philosophers. Okay, now I'm going to tell you a little bit about how I think, a little bit about how the talk is going to go from here. There's an ironic twist to my story. As I said before, the mechanist sought to portray scholastics as unnecessarily wedded to ordinary ideas about objects, perception, and causation. They replaced this ordinary image of the world, or so we're always told, with a stark, scientific, mathematically precise image of the world. But from Newton's point of view, the mechanists failed to understand that they actually retain a residue of the ordinary image of the world in their conception of causation. After all, why should we think that all natural change occurs through the impacts of material bodies on one another? What convinces us that this is the one causal model for understanding nature? Well, it's ordinary experience, perhaps, that convinces us. Because in our ordinary experience, we cannot, as it were, change the state of something, I won't push this over, but without impacting on it. The reason it sounds outlandish, for example, to say that the sun impresses a force on Jupiter is that this completely deviates from our ordinary ideas about causal interactions. Nothing in ordinary experience suggests that the sun could move Jupiter. The mechanists, despite their best efforts, therefore remain wedded to a picture of causation that emerges from our ordinary experience of material objects and their interactions. From Newton's point of view, we need to continue the mechanist project by jettisoning the last bastion of ordinary beliefs about causation, embracing the possibility that our causal notion, that of a force, can be applied to cases that do not involve impact at all. Newton spent the rest of his career, in my opinion, trying to make this conception intelligible to his critics, interlocutors, and even some of his friends. I describe this dialectic in greater depth in a few minutes. However, before I said there is a double irony, and this gets to the alternative title for my talk. We will see that the double irony is something like this. Just as Newton could portray the mechanists as wedded to ordinary causal beliefs with their fixation on contact action, we will see that Newton himself maintained an allegiance to a traditional metaphysical picture of substances and their actions that was itself wedded to ordinary causal beliefs. Hence, even Newton could not fully escape from the constraints on causal thinking imposed by our ordinary experience of material objects and their interaction. Okay, that's how it's all going to go. Now, I wanted to say one preliminary thing before I get serious. Preliminary thing is the following. Sorry. First of all, Newton never really gives us what we might call an analysis of causation like Hume does, or Kant later. He does not really ask the question, what exactly is a cause? I believe it's actually quite significant that if you look at definition 4, this is at the very beginning of the Principia, for those of you who haven't memorized it yet. Probably not a lot of people have, but before you even start book 1, he says an impressed force is an action. And if you say, well, what do you mean by an action? That's really a primitive. It's not discussed. He's happy to make use of the notion of an action, and then he gets actually quite specific and exact and precise in what he means by different kinds of force and how to measure them later. But in any case, he does not give the kind of analysis of causation you might be expecting in the world after Hume. And not only that, the second point would be also, he does not really try to overcome skeptical questions about our causal reasoning and our causal knowledge in general. Again, that would happen in a post-Humean context. The way I understand some of what Kant does, if anyone's interested, is Kant thinks Newton really gives us the best causal analysis we have of a natural phenomenon in Book 3 of the Principia. But because of Hume's skepticism, let's say in a broad sense, about causal reasoning, Kant has got to confront the questions that Hume raises head on. Newton really doesn't spend any time on skepticism about causal reasoning. Okay, now we're ready to start. The first concept of cause will be the notion of a mechanical cause. That's what I want to start with. Mechanical causes, understood as a species of efficient cause, were all the rage in the 17th century. Roughly, a mechanical cause can be defined as follows. One material object causes another to change its state by impacting on its surface. Classically, when Minnesota Fats hits a billiard ball with a pool stick, it rolls along the table, knocks into a neighboring ball, and makes it sail into the corner pocket. The basic mechanical notion of causation, if it is to be applied to nature, presupposes only that there are material objects in the world bearing our usual list of mechanistically approved properties: size, shape, mobility, and maybe impenetrability or solidity if you read Locke. Newton certainly never denies that there is mechanical causation in nature of this variety. It would be very odd to deny that. However, it isn't quite right to say that Newton endorses the mechanist understanding of mechanical causes. As with other revolutionary figures, Newton accepts very few prevailing notions in his day, including the prevailing mechanist notion of mechanical causation. But you might wonder, could there be a non-mechanist understanding of mechanical causation? What would that be? Well, I think Newton reinterprets mechanical causation And he does so in a way that would make some mechanists a bit uncomfortable. So, Newton's reinterpretation has two aspects. Firstly, he argues that we cannot know a priori, speaking anachronistically, I mean that in the more contemporary sense. We cannot know a priori that mechanical causation is the only variety in nature. Perhaps we could know that empirically, although as it turns out, Newton believes that the evidence points in the other direction, and he will tell us, at least in the case of gravity, that some causation in nature is not mechanical. I'll talk about that in a minute. But secondly, the second aspect of Newton's reinterpretation, Newton contends that we can subsume the fundamental notion of mechanical causation under the more general rubric of impressed force. Hence, as we saw before, he would prefer to say that when the two billiard balls collide, they impress forces on one another. Since force is proportional to mass and acceleration, this gives us a nice measurement of the forces that are impressed. And it gets us away from vague notions of pushing or speeding up or changing motion and so on. Now we're into a realm where we can give a measurement of something. Now, this reinterpretation of mechanical causation already raises some mechanist objections. In order for us to think of this reinterpreted version of mechanism as applying to nature, we must acknowledge not only that there are material objects in the world, characterized by size, shape, motion, and so on. We also need to think of the world as containing forces. Now, some mechanists are okay with that idea, and some are not. However, that isn't the end of the story. Because as you may be aware, saying that there are forces in nature also alters our conception of material objects. To apply the notion of impressed force to objects in nature, we must think of the objects as bearing a quantity of matter that Newton will call mass. Hence, we are now to think of material bodies as bearing a property in virtue of which they resist acceleration. And some mechanists would be uneasy with the idea that we can predicate an essentially dynamical property of material objects. But for now, I'm going to leave that aside. The idea is simply that Newton reinterprets the notion of mechanical causation within a broader dynamical framework. Okay, that's the first concept. That's pretty simple. We're going to get increasingly complicated. The second concept is the concept of centripetal force, or anyway, of impressed forces, but centripetal force would be the one I'm focusing on. As we saw a minute ago, Newton conceives of centripetal forces, such as gravity, as being one species of impressed force. And before he has identified gravity with the force that maintains the planetary orbits, he says that the force maintaining the planetary orbits is also a centripetal force, and therefore a species of impressed force. So before any arguments in the Principia appear, we have the following conceptual view. We can employ our causal notion of an impressed force, and we can apply it to cases in which the causally interacting bodies are spatially separated by millions of miles. So in the definitions, we're committed to the idea that it might be perfectly sensible to say the following: something impresses a force on Jupiter, thereby maintaining its orbit around the sun, or when a rock falls from the top of Mount Everest, I'm picturing, if you could get to the edge of Everest and it were a sheer plain, you drop it, let's say, and it falls thousands of feet. When that rock falls, something impresses the force of gravity on it, causing it to fall to the ground. Now, in the mechanist interpretation of mechanical causation, this conceptual view really will not do. Newton has inserted that some cases of natural change may not involve contact action between material bodies. After all, if you take our little rock, it seems nothing is hitting the surface of the rock. So a mechanist would insist that if we want there to be anything here more than a mere façon de parler, then we cannot apply a causal notion to the case of free fall. We should reserve any such notion for our eventual mechanist story, according to which, say, streams of particles push the rock toward the ground, or the center of the earth. So the mechanist would say, and in fact did say, that Newton had admitted a kind of non-mechanical causation into his thinking. This leaves open one question, however. What about Newton's reinterpretation of mechanical causation? Is gravity a mechanical cause just in virtue of being an impressed force on the reinterpretation? I think Newton himself answers this question. Now we're going to go to the next part of the handout. I guess it goes to the second page. I think Newton answers this question in a famous passage in the General Scholium. For those of you who don't know, the General Scholium was added to the second edition of the Principia in 1713, and it has been the subject of considerable discussion, debate, and so on over the years. I'm going to just read one part of it. And this is my translation, I'm pretty sure. But it doesn't deviate very significantly from Cohen and Whitman, which is kind of the standard. Okay. Here's how Newton answers our question about gravity. Thus far I have explained the phenomena of the heavens and of our sea by the force of gravity, but I have not yet assigned a cause to gravity. We'll get back to that issue of cause of gravity later. Indeed, this force arises from some cause that penetrates as far as the centers of the sun and the planets without any diminution of its power to act, and that acts not in proportion to the quantity of the surfaces of the particles on which it acts, as mechanical causes are wont to do, but in proportion to the quantity of solid matter, and whose action is extended everywhere to immense distances, always decreasing as the squares of the distances. So he gives you what he has said in the law of universal gravitation right there. This is one of the most famous passages in all of Newton. It clearly tells us that gravity is not mechanical because it is proportional to the quantity of matter or mass, and not proportional to the quantity of the surfaces of the particles constituting the bodies in question. It is not proportional to volume. And remember, for Descartes, quantity of matter is a function of volume alone. So this is, again, a way of saying Descartes can't possibly be right if he's going to try to understand gravity. Now, a mechanist would say that gravity is not mechanical because it does not involve impact. But Newton would say that gravity is not mechanical because it is proportional to mass and not to volume or surface area. Newton's view, actually, is epistemically symmetric here. Just as we cannot know a priori that all causation within nature is mechanical, in any sense, he certainly doesn't think we can know a priori that some causation within nature is not mechanical. We have to discover that in Book 3 of the Principia, which is what he's describing here in the General Scholium, by discovering the law of universal gravitation. Now, I hesitate to point this out, but I'll just say one little teeny tiny thing to complicate everything, and then I'll pretend I didn't say that and move on, but just in case people want to talk about it. This indicates that we might have to restate slightly what I said earlier. For Newton, even if we restrict ourselves to impressed forces in the case of an impact, we are still perhaps not dealing with mechanical causation, since all impressed forces are proportional to mass and not to volume or surface area. Of course, a mechanist would take impact to be a sufficient condition for mechanical causation. And if so, then she would disagree with Newton and say that our billiard balls do interact mechanically because there's an impact. It's just that Newton might not want to say that that's mechanical in his special sense that he introduces in the General Scholium. But I'm going to leave that aside because all of the action is really in the case of gravity and not in the case of impacts. Okay, so here's the upshot. According to both a mechanist and a Newtonian criterion, the Principia introduces non-mechanical causation into nature, although they mean different things by that. From a mechanist's point of view, this is forbidden because what Newton has really done is introduce action at a distance into nature. Thinkers such as Leibniz and Huygens pointed this out and objected vociferously. So of course I want to talk about that more. Before we get to that, however, I want to get to my third concept, agents as causes. Now, The first two concepts of causation are complicated enough, but as many of you are aware, Newton does not rest merely with endorsing. He immediately muddies the waters by telling us that he too, like Leibniz et al., rejects action at a distance. But how can that be, you might wonder? Trying to answer this question will end up showing us that Newton actually endorses a third concept of causation, which I'm going to call agent causation. As it turns out, despite his revolutionary work, Newton endorses a very traditional concept of agent causation, one with medieval roots and early modern offshoots. And in fact, it has, according to some people, ancient roots. It may actually go back to some readings of Aristotle's physics, but I'm not going to get into that today. So why do I say Newton too, like Leibniz, rejects action at a distance? Well, let me give you a quotation now. The next thing on your handout, from Newton's letter to Bentley. Let me introduce this briefly. Some of you may know Robert Boyle of the air pump and Boyle's Law fame was an independently wealthy aristocrat who, upon his death, endowed a series of lectures in London called the Boyle Lectures, which were designed to promote Christianity in some kind of reasonable formulation of it, and in particular to talk about how natural philosophy, as it was developing in the late 17th century in England, actually promoted a reasonable version of Christianity. Very standard kind of thing for many thinkers then. The first person to give the Boyle Lectures was a theologian named Richard Bentley. And as he prepared to give his lectures, Bentley wrote to Newton, essentially saying, I'll paraphrase, you have the coolest theory of anybody in natural philosophy right now. That was supposed to be a joke, but anyway. I'll think of a better joke. So tell me, what does your theory of natural philosophy indicate about atheism or views of matter that lead to atheism and a reasonable formulation of Christianity, etc. So Newton and Bentley exchanged a series of letters, and they're extremely illuminating because they happened in 1692 to 93, after the first edition of Principia had been published, and it was actually at a time when Newton thought of doing a second edition of the Principia, and originally Richard Bentley was going to be the editor of the second edition. That didn't turn out to be the case, and eventually Roger Coates did, many years later, publish the second edition. Okay, so here's what Newton says to Bentley. Now keep in mind, Newton is explicitly addressing the question, how should readers in general and the general public understand the theory of gravity? What are the implications of it? What is Newton committing himself to? This is what Newton says. This, by the way, was written in English originally, so this is not a translation. I just changed the spelling. It is inconceivable that inanimate brute matter should, without the mediation of something else, which is not material, operate upon and affect other matter without mutual contact, as it must be if gravitation in the sense of Epicurus be essential and inherent in it. Epicurus, I think here it represents the ancient idea of atoms in the void. They have a vacuum and the atoms interact. And this is one reason why I desired you would not ascribe innate gravity to me. That gravity should be innate, inherent, and essential to matter, so that one body may act upon another at a distance through a vacuum, without the mediation of anything else, by and through which their action and force may be conveyed from one to the other, is to me so great an absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. It's a reasonably strong sentence. Here's an amazing comment now. Gravity must be caused by an agent acting constantly, certain laws. But whether this agent be material or immaterial, I have left to the consideration of my readers. So there he's bringing back that issue that's also in the general schooling, what is the cause of gravity, which we're going to talk about. It certainly appears from this letter that Newton rejected the idea of action at a distance between material bodies. He didn't simply say there isn't any, as it turns out. he said it's an absurdity and also inconceivable. Very strong language, I believe, for Newton, who is usually extremely careful not to overstep what he thinks he can really show if you ever challenge him. That was one of his personality quirks, that he didn't like to be challenged, and he always wanted to say things in a very exact way so that if someone did challenge him, which of course did happen a lot after the Principia was published, and even in the early optics papers in the 1670s, he could bring a very forceful reply. So this is an extremely strong statement, and remember, this is not a private letter in the sense that Bentley said, you know, just tell me what you happen to think. This is because Bentley is going to prepare lectures given in London to the public under the name of Robert Boyle, the greatest experimentalist in England in the 17th century, certainly if you don't include Newton, or maybe even if you do. So Newton was speaking to a very wide audience here. Now, Newton does not address the action of immaterial substances here, as this was not relevant for his discussion with Bentley, but he does say that material substances, material bodies, cannot act at a distance. He also insists that gravity must be caused by an agent, which I'm about to discuss in more detail. But let me just say one thing about the end of the letter. It's sometimes thought that Newton's letter is a bit odd, since he first writes that material bodies require the mediation of something that is not material for them to interact gravitationally. That was the first sentence. And then in the end he writes that he's left the question of whether the agent causing gravity is material open. But that isn't odd. By his readers, he means the readers of the Principia, and not Bentley, the reader of this particular letter. So he's telling Bentley something about what he strongly believes that was left open in the Principia itself. Okay, 6 years after the Principia first appeared, Newton told Bentley that gravity must be caused by an agent acting constantly. But he told Bentley little about that agent. In the General Scholium, however, added to the second edition of the Principia, Newton tells us more about agents. And that's what I want to move on to now. This should be the next thing on the handout. Another famous passage from the General Scholium. I think... How am I on time? Can I read this whole thing? I guess I can. Okay. It is very important. Well, maybe I won't read the whole thing. Every man, I haven't checked the translation, probably every person would be better there, but anyway. Every man, insofar as he a thing that has senses, is one and the same man throughout his lifetime, in each and every organ of his senses. God is one and the same God, always and everywhere. He is omnipresent not only in power, but in substance. For power cannot subsist without substance. That's the key phrase. The original is omnipresens est non per virtutem solum, sed etiam per substantiam. And the key is nam viris sine substantia subsistere non potest. So I have translated that power cannot subsist without substance. In God, or in him, all things are contained and moved, but he does not act on them, or they on him. God experiences nothing from the motions of bodies. The bodies feel no resistance from God's omnipresence. What does this very striking passage in the General Scholium to the Principia indicate about Newton's third concept of causation, or agent causation? That's what I want to tell you now. Newton seems to argue in the General Scholium, or suggest, that God's active omnipresence entails God's substantial omnipresence, for action requires substance. This inference calls out for a clarification. Why should a substance be substantially omnipresent just because its action is omnipresent? By action being omnipresent, I mean God can act anywhere in the universe. Which, of course, all of Newton's readers would be happy to accept. Certainly, Descartes would have said that, Leibniz. So, if God wants to act on this piece of paper, God can do that. And it could be arbitrarily different point in space. God could do it anyway. But couldn't we have a substance that is located in one place and that acts somewhere else? After all, this is in the Principia, and Newton just got finished telling us before the General Scholium, which occurs after Book 3, that things like the moon and the earth and Jupiter act on the sun and vice versa, even though they are a great distance away. So he himself gave us a theory in which substances are located in one place, but act on things very far away. It could be arbitrarily far away, for that matter. Hence, there seems to be an invalid inference. From the fact that God's action is located everywhere, it should not follow that God is located everywhere. More specifically, from the fact that God's action is located everywhere, it follows that God's action is located at any arbitrary point P, like right here. But from the fact that God's action is located at P, like God wiggles my hand, it shouldn't follow that God is located at P. Okay, if we are to find an interpretation of Newton's inference that renders it valid, it seems to me we have to take it to have a hidden premise. Namely, a substance cannot act where it is not substantially present. Note, by substantial presence, I mean a substance's location, which we can talk about more if you like. But anyway, if we add this hidden premise, we get a nice argument, and that is here, I think. A substance S acts at point P. A substance cannot act where it is not substantially present or located. Therefore, S is substantially present at P, or located at P. And then you can apply this to God. Since God acts everywhere, unlike all finite material bodies, although gravity makes things complicated, but anyway, God certainly acts everywhere, therefore God must be present everywhere by this hidden premise. So according to the third concept of causation, a substance or agent cannot act where it is not. More positively, a substance acts where it is substantially present within space and nowhere else. Newton takes this to be, this is why it's so important that he's talking about God here. Okay? Newton takes this to be a general feature of agent causation because it applies even to God. Since we know that God acts everywhere within infinite space, we must believe that God is substantially present within infinite space. Since it applies to God, we know that Newton's view does not reflect any beliefs he may hold concerning the limitations of finite actors. You might have thought, well, I can only act where I'm present, but that's because I'm a finite being, right, who exists for a limited period of time, and there are many limits on what I can do, maybe because I'm tied to a particular body, so I can't make something move on the other side of the universe, but certainly God could do that. But that isn't the case. God can move something on the other side of the universe, but that's because God is there too. Not because God is doing it from over here, as it were, or from nowhere, for that matter. I should say that part of the background to this view is, I was talking about this before, Henry Moore's correspondence with Descartes. For those of you who haven't read this, I highly recommend it. Unfortunately, it's never been translated, which is a totally bizarre fact. So if you want to become world famous, work on your Latin and translate Henry Moore's correspondence with Descartes, get it published, you'll be world famous. You can give me 5 or 10% of the royalties for suggesting it. Anyway, in this correspondence, Henry Moore, who knew Newton personally, was famous in Cambridge when Newton was an undergraduate, before Newton got there, Moore gets Descartes to make various admissions about the actions of God and how they suggest God's presence within space. I won't go into that, but certainly Newton was very convinced by what Moore had argued, and in addition to other things Moore had written. And Newton thought the proper view of God, to really account for God's action everywhere within space, is to say God is present or located within space everywhere. So he rejects the Cartesian view that God is not located anywhere. Now, of course, we have a problem. How can Newton contend that the sun impresses a force of gravity on the Earth across millions of miles of space, even while contending that action at a distance is inconceivable, and that all substances act only where they are substantially present? How can the sun do something that even God can't do? This is what I regard as the great tension within Newton's causal thinking. Okay, and it leads me to the next section, resolving the tension. I'm going to distinguish in more depth between forces as causes and agents as causes. And hopefully I will convince you that there really isn't a tension after all. Here we go. I want to argue that Newton makes an implicit but actually quite robust distinction between forces as actions or causes on the one, or anything else that doesn't involve the quantity of matter or mass. The presence of those things within the space between the Earth and the Sun is ignored by the law of universal gravitation, and therefore does nothing to interrupt the dynamical relation between the Earth and the Sun. Therefore, to say that there is a distance between the Earth and the Sun is not to assert that there is a vacuum between them. It is merely to claim that they are at what we might call a dynamical distance. If you like, they occupy a dynamical vacuum, for there's nothing massive between their spatially separated centers. As a technical notion, impressed force is intertwined with a technical notion of distance. So I claim. Now, let's consider the notion of a substance and its action. That's the metaphysical notion. From Newton's point of view, to say that one substance acts on another is to say something that is sensitive to the discovery of a medium between the Earth and the Sun. Take the following example. Suppose there is a non-massive medium between the Earth and the Sun, a non-material medium, because, by the way, mass is essential to matter according to Newton. So when he says not material, it would be not massive. Suppose we discover a non-massive medium between the Earth and the Sun, one that somehow transfers the action of one substance to the other. In that case, it would still be correct to assert that gravity is a distant action, or force, between the Earth and the Sun, because the non-massive medium, as I suggested, is irrelevant for the question of the force. But that's not the case if we're focused on the question of whether one substance acts on another at a distance. For if the immaterial medium between the Earth and the Sun were discovered, it would indicate that the Earth, let's say, transfers its action through the medium to the Sun. Of course, that would mean there is no action at a distance between the Earth and the Sun. Remember that we're dealing with an instantaneous action. If you're wondering, well, how does this medium work? It's instantaneous, and that isn't a problem for anybody. At the end of the 17th century, that becomes a problem later. Another way to put this point borrows some language I introduced a moment ago. In Newton's theory of gravity, we have a dynamical conception of distance, such that two bodies are distant given their spatial separation and the lack of anything massive between them. But in traditional metaphysics, we have an ordinary conception of distance, such that two bodies are distant given their spatial separation alone. The non-massive medium does not disrupt the application of the technical concept of distance because of its dynamical irrelevance, but it does disrupt the application of the second conception. There's another way to distinguish forces as causes and agents as causes. So let me add that now. We know from the metaphysical tradition, and indeed from way back into medieval metaphysics, that each and every action must be attributed to some substance. As Newton himself says, action cannot subsist without substance. You can't have an action, something happens, without some actor that did it. Something's got to do that, according to the metaphysical notion. Now, this is a vague idea, and it gets elaborated in many ways, but that's already enough to distinguish it from impressed forces, especially those of the centripetal variety, like gravity. For Newton argues that his theory does not require us to think, and indeed does not license us to think, that gravity is the property of any body, or of material bodies generally. Let me explain. First of all, Newton certainly thinks that gravity is part of nature. In my favorite line in all of Newton, he says in the General Scholium, "Et satis est quod gravitas revera existat." It is enough that gravity really exists. Secondly, Newton thinks, in addition to that, that gravity is universal. All material bodies gravitate toward one another. He contends, thirdly, that the law of universal gravitation indicates how to measure gravitational interactions. But fourthly, he denies that we have sufficient knowledge to understand gravity through any particular physical model. We don't know whether there's a medium for gravitational interactions, and if so, what properties it might have. So to say that the Earth and Sun interact gravitationally is to say something along the lines I indicated before. But it is not to commit yourself to the idea that they exchange particles or waves, or there's some medium between them, etc. We have no knowledge of what he calls gravity's physical seat. Newton also wishes to deny that any physical interpretation of gravity that entails action at a distance among material bodies, he wishes to deny any physical interpretation of gravity that entails action at a distance among material bodies. So in the letter to Bentley, he says, he wants to deny that gravity is innate, inherent, or essential to matter on the grounds that endorsing that view would commit us to action at a distance. Here's why. If gravity were an essential property, then clearly it would not be dependent on a medium, because you could take it away as part of it, and therefore to exist even in the absence of a medium. That would mean material bodies act at a distance on one another. Here we are talking about the actions of substances and not merely of the force itself. But wait a minute, you might say. How can Newton tell us that we can measure gravity using the law of gravitation, even while remaining ignorant of gravity's physical basis? How can we measure anything without knowing what it is physically? I'm going to give you an analogy here that hopefully will help explain this. In the past, and I'm getting close to the end, I know I'm probably almost out of time. In the past history of science, many people were in a position to say that they can measure the temperature, say, of a room without knowing what temperature is. So they could say, for example, with the thermometer, it's, I don't know Celsius, so I'll say something crazy. 25? Is that all right? Okay, 25, it sounds freezing to me, but let's say it's 25. A little bit more? 20. Let's say it's 20 degrees in here. 21 degrees in here right now. That claim that we can measure the temperature wouldn't commit someone to the idea that the air in this room has a particular property, or that there are tiny corpuscles in the air moving in such and such a way, or anything else. You can measure temperature without knowing fundamentally what temperature is. And it took, of course, quite a long time to figure out what temperature amounts to. Newton has a similar situation. He says that we can measure gravity, which is an action, and like temperature, it can cause things. So the temperature in the room could cause you to sweat, presumably. You can make that claim without knowing what temperature is. He tells us we can measure gravity, the interaction of material bodies, without asserting that gravity is a property of anything at all. For Newton, his theory does not license the conclusion that gravity is a property of material bodies, or indeed of anything. That goes beyond our knowledge. Okay, for the conclusion, just a couple more minutes. Let me draw two conclusions from this episode. First, we can conclude, I think, that there is no tension in Newton's views after all. He can have his cake and eat it too. He can simultaneously assert that gravity is a distant action in a technical sense, even while denying that any substance acts at a distance. As the letter to Bentley suggests, Newton thought that some agent must ultimately be responsible for gravity. And he speculated at various points in his career that God might actually be the agent in question. Suppose for a moment that God is the agent. Then according to my interpretation, the following would be the case. Gravity would be a distant action in every case in which two gravitationally interacting bodies are at what I have called a dynamical distance from one another. But no substance would act at a distance, because the actions of all substances that interact gravitationally would be mediated by God, who, as you recall, is substantially omnipresent. Keep in mind, the cool thing about God is God is present not only at the surface of the earth, but throughout the entire earth. That helps understand, well, how could gravity, as he says earlier in the General Schooling, how can gravity go, as it were, right to the center of a body, where the center is what's important about it, and not, well, God can do that. Here's the second conclusion, or it's sort of a philosophical moral of my story. If you like, in his causal reasoning, Newton was a revolutionary physicist, but a conservative metaphysician. As I say, when it came to substances, even the infinite substance, Newton had a very traditional picture of causation that goes way back through the medieval period that really is wedded to ordinary ideas about causation. But the key to future developments in philosophical and scientific understandings of causation is that Newton very deliberately insulated the aspect of natural philosophy that we would call physics, which centers on discovering the forces of nature, from the aspect of natural philosophy that we would call metaphysics, which centers on substances and their actions. Remarkably, this is, I think, the most remarkable thing, Newton insulated physics even from his own fundamental metaphysical preconceptions about how actions must be attributed to substances. That insulation enabled physics in the 18th century to proceed on its merry way, even as it developed concepts and conclusions that greatly challenged the very heart of the metaphysical tradition. Thank you.